There are two laws of propositional logic that we use really a lot, and they're called DeMorgan's laws. And they identify these equivalencies. And this means that you can actually use one in place of the other. Since they're logically equivalent, when you're working with a compound proposition, you can replace something logically equivalent with it. And so these become really valuable when you're manipulating propositions. So this one is not, if you have P or Q and you not it, it's the same as if you take that negation operator and apply it to each individual variable and change the operator to and. So really you're taking the negation inside the parentheses and putting it by each variable, but then you swap the or to an and. Same, and the other version of it is when you have an and operation and you take the not of that and operation. That's logically equivalent to taking the not and bring it inside the parentheses by each variable and changing it to an or. Now we can establish this, the logical equivalence of this, with a truth table. So let's go ahead and try that. Let's just do the second one, and then you can do the other one as well on your own. But this one, let's do together. So go ahead and you create this table as we go. Now there's only two variables here. So we're going to insert a table. We need 4 columns for all the combinations, plus 1 for the labels. So we'll do 2 by 5. And then just make them a size that works. So a space for P and a space for Q. And then we want to do all the combinations. So here's P and here's Q. And I do like them centered, so I take the time to center them. And then I do all the truth values. And remember, you start with the rightmost and you just alternate true, false, true, false. And then you go to the next one, you do 2 truths and then 2 falses. And there we have all of our combinations for 2 variables. So let's start with the left, and we'll do inside the parentheses first, which is P and Q. So I'm going to insert a column to the right and copy down the P and Q and make it big enough so it fits. Maybe. Doesn't want to stick. All right, so there we have P and Q, and we just work out the values of that. So true and true is true, true and false is false, false and true is false, and false is true. Then we insert a column to the right, and now we're just going to simply not that. So we just take that previous column and make it not. And so a true turns into, a true is false when you not it, false is true. We do that three times, and that gives us the not P and Q. All right, so now we've got the result of the left side. Let's do the right side. And this one, we're going to do a not P first. So we'll just do this one because that not happens first. Bring that in. So not P, we just come back over here to where P is, right? And we just not it. So the 2 top truths will turn to false, and the bottom 2 falses will be trues when you not them. And then we do for not Q. So we bring down not Q here. And now it's the opposite of this one. So the true turns to false, and the false when you not it is true, and we get false and true. And then we insert a column to the right, and now we're going to do this whole combination, right? Because we're just really ORing those after we've knotted them. And so now we're going to just OR these, OR not P and not Q. So false or false is false. False or true is true. False or true is true. And true or true is true. And now we can compare them. So if we look at this column, we have false, true, true, true. And if we look at this column, we have false, true, true, true. And so here we've used a truth table to establish logical equivalence. So this law holds true that this the negative of P and Q is the same as the negative of P or the negative of Q. And that's DeMorgan's laws, and we'll be using these multiple times. So this is an important law for you to know and learn and remember.